Welcome to our live training session number 13, part 3. In this video, we're going to take a look at our closed loop tuning technique so we can dial in our idle and part throttle operation, as well as taking a look at the switching voltages and the behavior of our O2 sensors so that when we're using our closed loop, we're going to know if it's going to be valid or not. We're going to have a lot to learn, so let's jump into the live training session so we can get started. Welcome back here to our live training session with our C5 Z06 Corvette. In the last video, we went over the open loop tuning method, going in and taking a look at our air-filled air here, moving into our VE table, and applying those changes that we're finding. Now we're ready to take a look at our closed loop method. So we're going to be taking a look at a whole bunch of different things. We're going to be setting up some different chart versus time here so we can evaluate closed loop performance. We need to make sure the switching voltages are going to be correct for our narrowband sensors, and it corresponds to our wideband. It's going to be the very first thing we're going to do. But before we get into that, let's take a look at something that we ended the video in our previous video. We were starting to see when we came down to deceleration, and we can find here, this was actually that last go through in our open loop format here as we're driving through. We can find in our graph layout here, as I'm coming down, we can see that I'm decelerating here. I'm at 3,400, and then the red line here is going to be coming down. We can see as we're coming down here, if we're paying attention to what the RPM is showing us, our target idle speed 750, and we can find it's going to dip down here to almost 500, almost stall, and then we can find that it comes back up again and settles. Now what we don't see kicking in here is our throttle cracker airflow, and it wasn't going in and adding any more, and it should have been able to prevent it from doing this. That's the purpose of the throttle cracker. So we need to take a look at this in chart versus time in a little bit different way. Let me jump up here into layout. Let's go here into our add layout. Let's do chart versus time. And I'm going to be taking this chart versus time right here, and I'm going to be putting it right here. So we're going to be sharing it. We can find it's going to hide it right there. Let me jump in here. Let's right click. Let's go to chart layout. Let's get rid of these groups. I want to trim this down to one group here. And then in this group, we can get rid of the injector duty cycle. We'll have RPM, we'll have speed, and then we can plot some more information here. Let's go and do add series, and we can go here and let's do throttle. Label here. Let's go and add a parameter here. We'll type in throttle cracker. Actually, we'll type in idle, just so we pull up our idle channels here. Let's go into throttle cracker airflow. And we can see it's in pound per hour. We can label this throttle cracker, and that's not going to have enough room for it, so we'll just leave it right where it's at. So that's fine. Let's click close. Now we can find our throttle cracker here as we're driving is showing it's going to be operating here at 12 pound per hour. It's adding some in. And we can see our vehicle speed here is 75 mile per hour. We're driving on the dyno. But as we come down here, we can find as we're driving along and we start to decelerate, our speed here is going to be going down from 67 all the way down here to approximately, see it's at 10, we're at 2,400. Our throttle cracker here is adding 10 pound per hour as we come down. And we can see right here is the dip point. That's going to be where the RPM dips, and I want to get rid of that. We can see our vehicle speed is at 0. So the throttle cracker here is at 0. It's not doing anything. So what we need to do is add some additional airflow in here right before the speed goes down and it hits 0 in our throttle cracker table. We can find right here that that's just simply not going to be adding enough to catch the idle speed.